Grade 12 University Level Biological Processes CPT, Khalid Ahmed. The ingredient I have chosen from the first smoothie that David makes is milk. Milk is composed of the following: 87.7% water, 3.4% fats, 4.9% lactose, and 3.3% protein. Which specific nutrient is actually in milk? The answer is lactose. Lactose is only present in milk or dairy products. The following is a flowchart for the digestion of lactose, which is present in milk. It may look a little pixelated by now, but we will be dissecting this fully and going into each and every aspect of how lactose is digested and what comes out the other end. Firstly, lactose is taken into the body in the form of milk, which is present in David's peanut butter packed smoothie. It makes its way to the stomach, where bile from the liver breaks down the fats in milk, and enzymes from the pancreas help to break down other nutrients. It then makes its way to the small intestine. The small intestine is where the magic happens. The cells in the inner lining of the small intestine secrete an enzyme called lactase. Lactase catalyzes the hydrolysis of lactose into glucose and galactose, which can then be further used in the metabolic processes of the body to convert them into energy. Lactose is then broken down into its monosaccharides, which are glucose and galactose. Glucose can immediately enter glycolysis to produce ATP and pyruvate. Galactose, however, must undergo oxidation and enters glycolysis as G6P, also known as glucose 6-phosphate. These two molecules then go on to produce 4 ATP and 4 pyruvate. As each glucose molecule only creates 2, because there are 2 of them, they will create a multiple of 2, 4 ATP and 4 pyruvate. Alongside the production of 4 ATP, these 2 molecules undergo glycolysis to create 4 pyruvate and NADH. The NADH immediately enters the electron transport chain. The pyruvate further goes oxidation and from acetyl-CoA goes to the Krebs cycle. The Krebs cycle produces 4 ATP and more NADH and FADH. These 2 molecules also enter the electron transport chain, which then produces the most ATP out of all of these processes, a total of 68 ATP from both G6P and from 1 molecule of glucose. From glycolysis, the Krebs cycle, and the electron transport chain / chemiosmosis, a record of 76 ATP, theoretically, are produced. This is how the cells store and use the energy from lactose by converting it to ATP. The final question is, how will this benefit David? Firstly, lactose actually takes longer to be fully metabolized in the body than other forms of carbohydrates. This means that it will not be used and released for energy all of a sudden. Rather, it will have a staggered release in energy because it is being produced more slowly. This means that when he is running, it will allow for him to maintain a higher stamina throughout his run. Furthermore, lactose has a molecular weight of 350 grams per mole. This means that only 2 glasses of milk approximately would result in a theoretical yield of 76 ATP molecules, which the cells can then use as energy. Therefore, David will benefit by improved stamina and increased energy. The second ingredient is protein powder from the Green Machine smoothie. The main nutrient in protein powder is, of course, protein. The following is a chart for the digestion of protein and what it results to. Again, this will be fully dissected further. Protein digestion begins in the stomach, where an enzyme called pepsin catalyzes the breakdown of proteins. Furthermore, hydrochloric acid, which is present in the stomach, allows for pepsin to work and also aids in the denaturization of proteins.